Good afternoon. Welcome to the Federal Lab Consortium Showcase. I'm Nick Velasquez, your moderator for today's discussion. As a manager of Sandia National Laboratories and the Integrated Partnership Organization, I'm excited to facilitate our conversation on additive manufacturing and commercialization within the Department of Energy. Our first presenter today is going to be Mary Monson. She's a senior manager at Sandia National Labs. Mary is responsible for tech transfer and business development at Sandia. Her team actively fosters partnership with industry, academia, government, and other laboratories. Today, Mary will discuss technology partnerships within the labs and our Department of Energy Office of Tech Transfer Project, C4. The goal of C4 is to establish a self-sustaining manufacturing approach that supports various DOE laboratory missions. Following Mary's presentation, we'll engage with the discussion with Craig Blue, the Chief Manufacturing Officer and Director of Defense Manufacturing Programs at Oak Ridge National Laboratories. Craig's leadership and vision have been instrumental in the creation of the Manufacturing Demonstration Facility, MDF, at Oak Ridge. The MDF is a 110,000 square foot facility that houses integrated capabilities, driving the development of new materials, software, and systems for advanced manufacturing. Craig will share the partnering principles that have enabled the success of the MDF. We've allocated 15 minutes at the end of our discussion for questions. Please look at the question box and submit those in, and we'll get to those. If you have any questions, we'll be sure to address those. And if not, we'll work towards the end of the meeting to be able to at least find some answers or be able to point in the right direction. Today's discussion is being recorded, and we'll be reaching out with information that you can be able to access the recording. So with that, I'm going to hand it over to Mary Monson. Mary.
Thanks, Nick. Welcome, everyone. Tech transfer is a mission of all of the DOE labs. It's actually called out in our managing and operating contracts. And this mission has wide-ranging impacts, enhancing our ability to deliver on our mission and to innovate and remain on the leading edge of technology. Tech transfer has internal and external impacts as well, helping the nation secure its long-term competitiveness in the global market. Collaborations with industry, small businesses, universities, government agencies, and other labs brings new technologies to the marketplace and contributes to the economic well-being of the nation. Over the last 20 years, an estimated 140+ billion in total economic impact nationwide and over 72 billion in sales of new products and services resulted from Sandia's cooperative research and development agreements and patent licenses. Just a few of our technologies here that have been commercialized over the years. The technology behind the world's first commercial fuel cell ferry, synthetic aperture radar, decon foam, which was used extensively during the pandemic, and of course, the clean room technology. C4 is a Department of Energy Technology Commercialization Fund project sponsored by the Office of Technology Transitions, and it's focused on co-location, collaboration, community, and communication. The project's goal is to create a strong regional clean energy commercialization ecosystem for advanced manufacturing. The ecosystem will broaden Sandia's impact on the nation by removing barriers between labs and business, encouraging our staff to commercialize their technologies, and applying tech transfer approaches more broadly across Sandia and the DOE lab complex. We envision the C4 ecosystem as being anchored by a new facility launching at Sandia called Camino, the Center for Advanced Manufacturing Innovation. Today, we've secured an interim facility for Camino in Sandia's Science and Technology Park right across the street from our laboratory. A little bit about the hub and spoke model. As we stand up Camino, we are engaging with Oak Ridge National Laboratory to develop this hub and spoke model. Oak Ridge has established their manufacturing demonstration facility, and that was stood up in 2012. The MDF focuses on early stage R&D to improve the competitiveness of US manufacturing. So what we're going to do is take lessons learned from the MDF, which as you see here is the hub, and apply them to Camino, the first spoke. We'll be documenting the approach, and then we will proactively work to implement this model at future spokes. Our hope is that in documenting the process, we'll be able to replicate the model at other labs to stand up their own spokes, and each dedicated to a unique technical concentration with DOE missions involved. For example, Camino will support missions including energy and those within the National Nuclear Security Administration, such as rapid nuclear deterrence component production. Next. Partnerships are a crucial piece of establishing the C4 hub and spoke model and building out the capability of Camino, the first spoke. C4's ecosystem is comprised of a variety of partners, including other national labs, universities, local small businesses, and community members. These partners dedicate people, time, and resources that, when combined with C4 and Camino investments in R&D, lead to increased competitiveness, partnering, and attract further investment. Next. So something this audience may be particularly interested in, we've worked a lot on streamlining agreements. We've looked at 3 pathways for doing this. We were able to bundle IP and use a short form test and evaluation license, develop a new master scope of work, and we also have the option of using an access CRADA. And I'll explain each of those. The IP bundle consists of manufacturing related IP from 7 partner labs at approximately 60 patents. The IP bundle can be licensed through a limited term license and enables companies to test and evaluate technologies at no cost. And the feature that I really like about this is it's one license that includes 7 partner labs. So much easier for the industry partner. The C4 master scope of work was approved in January of 2024. The master scope of work allows DOE labs to have an envelope of work approved by their site or field office that the labs can then self-approve transactional agreements under that envelope. And so we've already had a few agreements put in place under that MSW, and we look to utilize it for all of our agreements done at Camino. C4 has also made the Access CRADA available. An Access CRADA provides the opportunity for multiple labs to join an existing umbrella CRADA that one lab established through a one-page implementing agreement, and then the joining lab can negotiate their own projects and statements of work without having to negotiate a whole new CRADA. So the combination of these options is expected to accelerate the partnering process. We've even realized a reduction of 200 days in some cases, and allows for easier matchmaking and partnering across the complex. We'll now see a video.
Yep, thank you, Mary. And we will get started and have the video of the MDF. Okay. Now I'll ask, oh, there he is, Craig. It looked great in the video, Craig. I'm really excited that we have you here today to talk about the MDF and the partnering principles that went into the MDF to make it so successful. So if you wanted to start, Craig, and just say a few words about yourself and how did the MDF start and where did the idea come from?
So thank you, Nick. Appreciate the introduction earlier. Enjoyed Mary's presentation and the video. I think is ideally suited. That being the first MDF Innovation Days, kind of capturing the ecosystem that has evolved out of the MDF. Kind of looking back 12 years ago, actually we worked real close between DOE's at the time Industrial Technologies Program and then DOE's DARPA DSO, Defense Science Office, specifically Leo Cristallo, and at DOE Douglas Kemp. And we were looking for a new innovation model that really leveraged the core capability of the national labs, in this particular case, Oak Ridge National Lab. We started by really studying the various public-private partnerships around the world, that including the Fraunhofers in Germany, the AMRCs, Advanced Manufacturing Research Centers in Sheffield, our own like EWI and Sematech, and we evolved a model really that spins around place-based innovation, taps into the large ecosystem here at Oak Ridge, now with over 6,000 employees, and really brings cross-disciplines together. So in many respects, more like a Bell Labs, a Skunk Works, where you bring people together with diverse backgrounds, engage industry, which really understands what the manufacturing problems are, and then put this team focused on it to rapidly go from basically problem to solution. And so we launched in 2012, just a handful of us, probably less than 10. Today, there's actually a manufacturing division at Oak Ridge with over 200 people, a lot of them residing inside of the MDF, and it's seen tremendous expansion. We'll talk a little bit more about that next.
Awesome. So I love the idea of Skunk Works and bringing the right people together and then being able to share those ideas to help, create something that's larger and that can gain traction. With that core group of people that you worked with, what were some of the funding principles that guided you throughout the process?
So, as I said earlier, basically place-based innovation. So bringing industry with the challenges, staff with the technical background, and then the facility having state-of-the-art equipment. Putting those three legs together to really go after problems. Another thing that was really crucial is this tech collaboration program that we evolved within it. So we have a core program, and this is DOE's Energy Efficiency, Renewable Energy, Advanced Materials and Manufacturing Technology Office today. At the time, it was the Advanced Manufacturing Office. We have a core program that really takes low TRL level, kind of great ideas, and starts to work with them and kind of march them up to TRL level. And then this tech collaboration program sits to the side of that, which is smaller, but it starts with a 40K and then a 200K project. But what it is, when industry comes, they sit down with a diverse team, actually lay out what their manufacturing challenges are, and then hopefully by the end of the day, you're able to put together basically a 2 to 3 page white paper that's sent to DOE headquarters, AMTO in this case, and they give it a thumbs up or a thumbs down. If it's a thumbs up, we move towards basically a fast track CRADA and take the concept that we come up with into a funded project in the matter of just 2 to 3 months. Phase one being 40K. That 40K is actually spent inside the MDF. Industry usually matches that with a 1-to-1. And then a phase two, again, 200K and 200K. What's great about the CRADA, a lot of the companies like, is the fact that if they create, they own the IP. And then if we create, we own, but they have first right to our IP. And then if it's jointly developed, then you have undivided rights. And then again, the company can get access. And to date, the MDF's done about 280 of these across the country. So it's been a very successful model. But I think that tech collaboration is really always pushing the envelope in what industry is moving out on next. And we do about, on the order of about 6,000 to 8,000 visitors a year here. So in many respects, Nick, it's like we're doing workshops on a daily basis.
That's
so
amazing.
I think those are key elements to the success of the NDF.
I think typically what we hear as national laboratories is many a times we're closed off and not able to partner. And the MDF has shown fabulous successes in being able to partner and being able to open up the capabilities of the national laboratories to move commercialization forward. What are a couple of examples that you can think of that are the biggest successes within the MDF that enabled innovation and success for industry and for manufacturing at large?
Okay, so kind of continuing on what I just talked about, as part of these creatives, a lot of the time, the companies in their cost share, they'll actually put equipment on the floor of the MDF. So over half the equipment inside the MDF is put there at no cost. It's part of the proper research and development, the in-kind, and kind of pointing some basically creatives forward and talking to them. One would be like with GKN. They actually worked with the MDF and built the first laser wire system for titanium deposition. Titanium typically has an 8-to-1 bi-to-phi. So for 8 pounds of raw material, 7 pounds gets machined away, and looking at building basically aerospace components directly. We co-developed their first system here, also work with Midwest Research. Their second system, just recently in the last month or two, GKN opened a facility down in Texas, 104,000 square foot facility, where they put their third system, and then now they're porting system 1 and 2 from the MDF into that facility down in Texas. You know, really that commercialization, we worked on everything from the equipment itself, of course, all the material science, controls, the integration of these teams with different backgrounds. So that's a really solid example. On the polymer front, we can talk about the fact that this goes way back to the beginning of the MDF, back in about 2012, 2013. We developed a large-scale polymer printing. Prior to us getting involved, Stratasys had the largest system in the United States, and everything was printed inside of an oven. One of our researchers, Blossmill Kuntz, with a team, discovered that during the extrusion of pellets that have reinforcement, it aligns the fibers. And in doing so, when you print, it constrains the material because it has a very low CT along its axis and keeps the dimensional stability when you're printing these polymers. And that allowed us to get outside of the oven and actually print much larger. And what I mean by much larger, on the order of 20 foot long, 8 foot wide, say 8 foot high. And that's not the largest system. Today, there's 7 different companies in the U.S. making these machines. Additive Engineering Solutions up in Akron, Ohio, actually serves as a printing service bureau, if you may. I think they're running on the order of 6 to 8 different machines, printing tooling for aerospace, tooling for precast concrete, things of that nature. The Domino Sugar Building of New York, actually, the whole exterior came off of printed molds. A mold usually will last, it's usually made out of wood with resin, 2 to 3 pours. These basically fiber reinforced molds will go to 220 pours per mold. Actually, the concrete, polishes them. Those are 2 different examples. There's others as well, but kind of from the polymer side over into the metal side, where basically from lab to really steel and concrete coming out of the ground, real companies.
So, Craig, I'm curious, just all the partnerships and things that happen, how typically do industry engagements go with, and what sort of energy and excitement does that bring to the MDF?
So we found that working on the right problems with industry, actually, I think it takes the staff excitement level to to really new heights. And the fact that when you're working on something, it's where the rubber hits the road. A lot of times, what I like to say is, industry comes in here, they got 80% of the solution, 90% of the solution. They've already got buy-in kind of up the chain inside the company, their board. This is where they're going, but they're having a particular manufacturing challenge. And I think that our people really rally around that. And it also allows the staff to see what they work on actually get transferred to industry almost real time. It's amazing when you're working with the industry. Sometimes, 2-3 months, you'll go from this unbelievable meeting to actually performing research that moves the needle. We've had companies actually grow and actually be acquired within a year of actually working with us. And for researchers, I think that's exciting to see your work actually get commercialized and get out there and really impact, the U.S. tax base, right? I mean, because that's what we're being paid by, is the U.S. taxpayer. So that's exciting. It's something I've personally thrived on my whole career. When I was younger, I worked on turbochargers. I always like to say we developed a whole new rapid heating technology, Nick, that drastically reduced the processing and cost of turbochargers for diesel engines. And every Cummins going down the road has our turbocharger in it. And there's over 5 million that have been made. And to me, that's exciting.
That's incredible. I think the one thing that I take away from visiting the MDF is, one, it's very unlike most government facilities that you go to. One, you pull up to a parking lot, there's no gate. You walk through the door, you see the printed car that President Obama signed and President Biden signed, and that was printed at the MDF. And being able to simply walk through this facility and see how much it's grown and the vision and the passion that it has behind it. Can you take me through some of the lessons that you've learned over the last 10 years that enabled this sort of rapidly molding, agile facility that's really accessible to the public?
Yeah, and so to your point, so Oak Ridge National Lab, the main campus, is about 10 miles from our Hardin Valley campus, and that's where the MDF resides. Actually, the first MDF and then the second MDF. We started in, the first MDF was on the order of about 42,000 square feet, and the host of us working together, I say it took us a few years while we had a great vision to figure out what were the pinch points, what do we really need to be working on in additive. And then we kind of got the model working well, where companies started co-locating. At one point, 90% of the equipment inside the MDF was provided by our industry partner. And then about 2019, we moved into a new facility, 110,000 square feet, and it took us 18 months to fill that. So our previous building would have fit inside the high bay here. So the model started to really take off. And we also got engagement not only from the advanced manufacturing office, but also the nuclear side, wind, water. Others started to actually realize that this model was a tremendous way for companies really to tap the capabilities of the National Lab. I like to look at the MDF as kind of a portal to Oak Ridge National Lab, because it's not only the MDF, but it's a lot of the core science tools that we have on the main campus that, working with the industry, we can get access to the tools that they may need. So we become a translator in many respects. So in terms of lessons learned, really, which out time and time again, because early on there's questions about the numbers of visits that we have. Those visits are the absolute lifeblood of the facility. I always say a very little secret is a lot of these innovative ideas that we have, actually, they're building off of what industry, has brought to us. And they're going to, almost by definition, keep your finger on the pulse. What's going to be over that next mountain, that next ridge. And we like to say, everybody's smart. So get people together, make sure that everyone gets an opportunity to step forward with their ideas, and really bring them forward in a substantive way. So I think, this engagement with industry, the co-location with industry. Another one that I haven't mentioned that's really important is the university interaction. Talking about bringing energy, you mentioned that earlier. Students inside the facility bring a ton of energy. They're young, they're wide-eyed, they're just so excited to get around the technology. And I think there's also been a transformational change around the area of manufacturing over the last decade plus. I think if you go back 15 years ago, people think of manufacturing and smokestacks, additive and subsequent technologies have really changed that. And it's much more than additive. We've kind of routed out our portfolio and the realization that machining and machine tools are very important to this country. We have a large machine tool effort with the Office of Secretary of Defense, Industrial Base Assessment and Sustainment. I think the whole digital thread, we're very strong on the front end with our data analytics, modeling, and coupling these all together with your non-destructive evaluation, kind of front end to back end, has been really important. And we're really looking to convergent manufacturing, bringing everything together inside of one system now, Nick.
So, Craig, I think one thing that has always stood out to me about the MDF is really, your tie to the region and what makes the MDF unique, and even talking about how, within 8 hours, you're within some of the major hubs of the United States, and that's a competitive advantage. And thinking through some of the new areas within advanced manufacturing and some of the opportunities they have that are specialized to their region. Can you talk a little bit about the principles you have around, finding routes where you're at, and being able to use your ecosystem to create this vision?
Yeah, absolutely. And so you take a step back, and you're looking at the region. To your point earlier, we're a day's drive here in East Tennessee. It's where Route 40 and 75 come together, and we're a day's drive from 2/3 of the United States population, which really matters to small companies. And when you look at manufacturing, about 98% of them are SMEs, small and medium-sized enterprises, less than 500 people. So the ability to drive is really important. Another thing in our local ecosystem, we have the University of Tennessee right here with over 28,000 undergraduates, probably on the order of about 7,000 graduate students. Really important. All your manufacturers are looking for those tier 1 universities because that's their workforce. And having students working on their projects is there for a future workforce. So the University of Tennessee has been really important. Also our local community colleges. But with the University of Tennessee specifically, we have what we call governor's chairs, and it's a joint position between the University of Tennessee and Oak Ridge, and they're basically highly sought after individuals that come and actually bring a lot of strength and reputation. In the area of additive manufacturing, we brought Suresh Babu from Ohio State, and the composites, Uday Vadia heading up our composites, and then Tony Smith in the machining area. So we have direct ties into the university, and they have direct ties into us. Also the university, the junior colleges. We've also done some very innovative things with the state of Tennessee, where we created a voucher program. So when companies come to Tennessee and they're looking to potentially locate here in Tennessee, they, as part of an incentive package that the state puts forward, it's called a REV program, they'll actually get a voucher to get access to our innovation ecosystem, both here at Oak Ridge as well as University of Tennessee. So over the years, we kept on adding and saying, what else can we add to our ecosystem? The Innovation Crossroads, this is basically an entrepreneurial program that was started by the Advanced Materials and Manufacturing Technology Office, former AMO. That is actually where companies are spun into the lab, and they get a stipend and they get a voucher to get access and actually create kind of the first business plan. So we have a lot of these things that we've put in place over the last 8 to 10 years that's created this larger ecosystem, and it's getting to the point where it's becoming self-sustaining and kind of going on itself at this point. Just last year, University of Tennessee opened what they refer to as Tennessee Made. It's about a mile from the MDF. It's on the order of about 60,000 square feet. It has machine tools, additive, directly coupled into our efforts. Also workforce development through America's Cutting Edge, which is a machine tool online course. I think there's on the order of about 9,000 people have taken it over the last few years. It also has incubation space for companies that want to come and co-locate, and they can even sell out of that location. So there's a lot of different facets, Nick, that have evolved. One other thing to the root of your question, though, we've now reached out and we launched a hub and spoke program with the University of Maine. This goes back a few years ago. where they had a paper industry that was struggling and they were looking for a home for their feedstocks and they wanted to get into additive manufacturing. So we developed a program with them where we bring our additive expertise, they bring their bio feedstock expertise, and then they kind of to the front line in terms of additive. Don't make all the mistakes we made. They learn by what we have, coupled in our partners, and now they're doing world-class research in additive manufacturing, large scale, very large scale. They have the largest printer in the world there. They can print up to 500 pounds an hour of polymer with reinforced materials.
That's awesome, Craig. And that absolutely gets to kind of where I want to go with my next question is, how do we apply the principles that you and your team have created and then be able to extend those? Sounds like you've already had some incredible success with the University of Maine. Are there any other examples of that? And what sort of advice would you give to those here on the call or watching this video about standing up this model and being able to replicate it?
And so I think, Mary laid out at the beginning, we're obviously working very closely with Sandia, with Camino, and we've engaged and shared all the lessons learned. I think it really important is at the front end, Nick, is doing a SWOT analysis of your region, right? And because really important is not only your local ecosystem, but where's your state investing and so forth? Because at the end of the day, real success is when the state incentives come in and companies are building buildings. Ultimately, that's what we want to do, right? Is take technology out of the lab and into production. So being strongly aligned with your state vision, local vision, understanding your strengths, your weaknesses, trying to fill in the weaknesses where need be. But I think those are the sorts of things. Now, we've engaged not only Sandia, but we've engaged the Kansas City plant. We're working with 4 other states and looking at their ecosystem and how we can port our expertise in with their expertise and help them start similar type efforts. As you know, manufacturing is about 11% of GDP. We have to replicate, make sure the United States is strong and that we're competing internationally. So we have a tremendous interest in sharing lessons learned.
Awesome. Where do you see the MDF model going over this next decade?
So I think here locally, the MDF will continue to grow. I think there's tremendous opportunities across the DOE offices. I mentioned earlier, there's a lot of interest from, the nuclear program, wind, water, geothermal, and we continue to engage in those areas. Again, bring the kind of the model in. And then I think beyond that, as I mentioned, we're engaging other states. I think a lot of what you guys have done at Sandia with the C4 model, I think that's the tip of the spear in getting more labs engaged. I mean, you could potentially look at a national hub and spoke model that really gets access to, our national lab system and make sure that we can pull, where appropriate, the technology and staff out to really have the biggest impact for manufacturing. So, I mean, I think it's something that could go national. And I really applaud everything that Sandia has done with their C4 model. You guys have been amazing as we work with you guys over the last year and a half or so.
So, Craig, I get so excited just, seeing things work and then seeing awesome impacts that we can have to industry and to the nation. I want to talk to you a little bit about, how do you bring fun into your work environment and continue to keep people energized, especially with such a long project over a long period of time, with so many diverse deliverables and different places that you can go. What are some of the principles that you bring to work every day to be able to keep things fun and exciting?
Yeah, and so I think as much as anything is having real bogeys. Something that we started early on was what we refer to as moonshots. When Lonnie Love was here, he was big in pushing moonshots and look at some audacious goals, right, that are way out there. I'll give, for instance, when we printed the first car up at IMTS, the International Manufacturing Technology Show in Chicago, that was audacious. Real-time printing a car in front of, over 100,000 people and driving the car away. Also credit to Jay Rogers, Local Motors, that helped evolve that vision. I think as much as anything, though, is something people can rally around. At the end of the day, it was really proving out the size, the scale, properties, a lot of other things that ultimately realized itself in tool making and mold making and that sort of thing. So we on a yearly basis try to have 1 or 2 moonshots where we can rally around that. And we'll be doing something at IMTS again this fall. It'll be unveiled. It'll be something that's, far reaching. But what we want to do is make sure that we're kind of a beacon, the tip of the spear. This is where the technology can go. And then industry comes around and says, this is really where it belongs. But what's the art of the possible? You never know, really the bounds until you go beyond the bounds. And I think we have a lot of people that really thrive on that sort of thing and take on big challenges. And then to me, that's extremely exciting. I like when we have visitors involved with the tours a lot of times because we've grown. I learn during the tour. I'm like, oh, I didn't know we were actually doing that. So we have a lot of innovative people that are thinking outside the box, getting that industry cue, and be able to really apply a lot of the science tools that we have here at Oak Ridge.
Awesome. Last question that I have is you've done such an incredible job building this model with your team and being able to make this what it is. What are your principles for passing down this culture and being able to ensure that it's enduring at Oak Ridge and being able to help bring along those early career staff members as well?
So I'm glad you brought that up. That's super important, Nick. And so I feel pretty good that we have one generation that's beyond mine. Of course, I've been here to life for 29 years, so and been along for this entire ride. But we engage young staff early. Me personally, I go out and have lunch with up to about 12 of them, every so often, making sure that we engage and that they see really the vastness of opportunity at Oak Ridge National Lab. Same, I'm sure, holds true at Sandia and other national labs, and all the different things that they can potentially, explore and evolve into, letting them see the inner working of how this all comes together. So we start mentoring staff early. We also look at, kind of rising stars, make sure that they get the proper training and overlap with some of our senior staff, making sure that we hand down best practices and so forth. So this is something that we're very forward leaning on and making sure that the ecosystem continues to grow. And so, this is something we do on a regular basis. We also have a meeting at least once, if not twice a year, laying out the strategic plan for the MDF. Where's it going to go? Where's it going to grow? Where are basically a SWOT analysis, right? Where are our strengths, our weaknesses, and so forth. I think it's really important that we're not rigid. We're an evolving organization. Keeping in mind that everyone that comes through the door, they're smart, listen to them. The next best idea might walk through the door. And I think that's kind of the way that we all think here. Be open. Again, innovation happens when you get people with different ideas, different backgrounds coming together. And that was really the crux of what the whole MDF was about. Get people together with different backgrounds versus everybody having the same training. A lot of times you get incremental advances. You can get revolutionary ideas when you get people with different backgrounds working together. And so we're nurturing that ecosystem and make sure that we keep it.
That's awesome, Craig. I know I could talk to you all day about this, and we've sat for feels like look down at the clock and it's 2 hours as far as the model goes and all the incredible things that MDF has done and that the entire team at Oak Ridge has accomplished. We did promise about 15 minutes here for any questions. Jamila, it looks like I'm not sure if we have any questions from the audience so far, but if there's any one we can drop in the chat or drop some questions in. Now's the time to be able to take some.
So one other thing, Nick, with one moment here, at the end of the day, it's all about your people. I mean, getting people with belly fire, making sure they understand the roles and responsibilities. none of this would happen without great leaders. And we're very fortunate to have, a large, basically, contingency of great leaders. At the end of the day, that's what it's about, is your people, because that's where the drive comes from, the enthusiasm. If we're going to start a new initiative, there has to be a leader in place. And we're very fortunate to evolve leaders, recruit leaders, and so forth. So it's all about the people. I want to be very clear.
Awesome. We have no questions so far, so I'm going to start making up a few questions for myself. One, if people want to learn more about Oak Ridge or the MDF and to be able to potentially go on a tour, what's the best place for them to start, and where can they reach out to?
Okay, so clearly they can reach out to me. Ryan Dayhoff is the MDF director. They can reach out to Ryan Dayhoff, and we can put that name forward. Bill Peter, he's over our Advanced Materials and Manufacturing Technology office, is another one. Bob Slattery is over our industrial collaborations. So we have a whole lineup of individuals that can be reached out to and arrange for a visit to Oak Ridge, the MDF, and so forth. We do tours even for larger groups of people, particularly in our local ecosystem. I think it's important for the next neighbor to really understand what Oak Ridge does, what the MDF does. I mean, it's important.
Absolutely. So I'll go with another question of mine. How do you balance a lot of the work that you do for other government customers and for defense, the Department of Defense, and some of the commercial activities that you have? Is there some sort of balance that you have, or how do you approach very different mission sets or different applications, and how do you find commonality within those?
Yeah, so what's really, I think, appropriate and convenient, a lot of times if we're going to do something over, say, in the DoD space, it usually comes from the fact that there's a visit by one of the services. They actually see a capability and say, we might be able to apply that here. So while maybe the application of the technology is different, it's using one of our core technologies. And as I mentioned earlier, additive, of course, is a core technology. Carbon fiber and composites is a core technology area. Machining and machine tools is core. The whole digital thread and advanced simulation, and all these are really core. And so it's applying those capabilities, utilizing those staffs, basically in a different area, but it's again the same technology from a processing, manufacturing, and so forth. So we're very intentional on what our strategic vision is. We stay inside that bound. To have excellence, you have to have focus, and so we stay inside of our own guardrails and we move forward. And so there's a balance between, say, DOE and other work. Of course, when we work with industry, a lot of times it's application of these technologies, and ultimately they're the ones that are going to, save energy, reduce carbon footprint, and so forth. So it's really ideal. And as I mentioned earlier, we even have, co-location with our industry partners. We always say the best tech transfer is actually people. Throw a technology over the fence, more likely it won't work. Work side by side. So that's, I think, in essence, the best way.
So I have one more question, and we'll see if some more roll in. But on the idea of a digital thread, and obviously with additive manufacturing, the whole idea is needing to go fast. How do you feel the pull is from the nation to be able to go fast? And can you speak to a little bit as far as needing that resiliency in our supply chains and being able to go fast, and what that means for the future of our country?
Sure. So I always, it's starting to get dated, I'm going to have to update. McKinsey came out with a study in 2017 that really talked about the digital thread and the need for our small, medium-sized companies to embrace it. At that time, they said, really, the digital thread is going to be absolutely necessary if you want to be agile. What I mean, go from, say, product A today to product B tomorrow. And things like additive and so forth allow you to potentially do that. And I say potentially, but you also have to have sensor technology. You have to have the ability to have closed loop controls. Make sure that you can go from CAD drawing to a part and then ultimately qualify your part from the data. Because if you can do small lot size, it allows you to have a lot of agility. And then you can get more individuals in the supply chain versus I have to have a million of one thing. And by definition, that stabilizes your supply chain. We saw a lot of the supply chain challenges during COVID, right? And I think that the digital, basically, thread and the application thereof could really open up new frontiers. Ultimately, think about if you had a drawing for a part and the requirements and kind of, and this is, I have to credit people like, you know, Lonnie and others, you know, kind of this Uber idea where I put the drawing out there, I put the requirements, and you could take kind of the digital thread and take it into the small and mom and pop shops and be able to make parts real time. And they're all identical. That would be, you know, I think that's ultimately the vision. You know, Tom Kerfus from Georgia Tech, he was a big believer in this, kind of the Uber of manufacturing.
Awesome. So I don't have any more questions. We're almost here at time. I wanted to thank you, Craig, if there's any closing thoughts you have, and also thank you, Mary, for jumping on for the presentation today. Any closing thoughts from you, Craig?
Well, first of all, again, I want to thank you, Nick, as well as Mary and DOE for the opportunity to basically discuss, you know, the MDF today, also the C4 model. You guys have done a wonderful job there. And I'm really excited about how we're going to move forward as a nation and impact our manufacturing, which is absolutely critical to the U.S. So I just want to thank everybody for the opportunity.
Thank you, Craig. Mary, any closing thoughts?
Yeah, I just wanted to emphasize the importance of partnering and tech transfer for all of us at the national labs to be able to deliver on our missions. Both our commitments to our government sponsors, but also on our tech transfer mission to strengthen the U.S. economy.
Thank you. With that, we'll wrap today. I hope you found this to be an informative and as insightful discussion as I did. And again, thank you all for your time. Have a great afternoon.
Thank you.